In the depths of our planet's most alien realm, where sunlight has never dared to venture, a creature of impossible intelligence dwells in solitude. It possesses 3 hearts that pulse with ancient rhythms, blood as blue as the deepest ocean trenches, and a mind so sophisticated it can solve puzzles that baffle creatures with lifespans 10 times its own. Yet this master of disguise, this underwater genius, lives by a biological clock so cruel, so unforgiving, that it transforms every moment of its existence into a race against time itself. Welcome to Animal Uncovered. I'm your narrator, and today we dive into the extraordinary world of the octopus, a creature whose life story reads like a tale of brilliance, sacrifice, and the most exquisite tragedy nature has ever written. Chapter 1. The Dance of Death. Picture, if you will, the rocky crevices of the Mediterranean seabed. Here, in the twilight realm where shadow meets stone, a male octopus emerges from his den. He is Octopus vulgaris, the common octopus, though there is nothing common about what he's about to do. His skin ripples with colours that speak a language older than words. Reds cascade into browns, whites flash like lightning across his mantle. He's searching, driven by an ancient imperative that will seal his fate. For in the world of the octopus, love is quite literally a death sentence. The female he seeks is larger, more powerful, her den a fortress of carefully arranged shells and stones. She could easily mistake his approach for that of prey. One wrong move, one misread signal, and she would consume him before he could fulfill his purpose. But evolution has equipped him with one of nature's most extraordinary solutions. Hidden beneath his skin, coiled like a secret weapon, lies his hectocotylus, a specialized arm that serves as both his reproductive organ and his final act of devotion. As he approaches her den, his skin flickers with what can only be described as nervous energy. The female, 3 times his size, watches from the shadows. She has seen suitors before. Many have not survived the encounter, but this male is different. Perhaps it's the urgency in his movements, or the desperate beauty of his colour display, but she allows him to approach. What happens next is one of nature's most intimate and tragic exchanges. The male extends his hectocotylus, this specialised arm, toward the female. In a process that takes mere minutes, he transfers packets of sperm, called spermatophores, into her mantle cavity. It is a moment of biological poetry, this passing of genetic material in the cathedral darkness of the ocean floor. But the price is absolute. The male's hectocotylus detaches, literally breaks away, remaining inside the female as he retreats. He has given not just his genetic material, but a piece of himself. Within days, perhaps hours, he will die. His body will shut down, his colours will fade, and the ocean will reclaim him. For the female, this is only the beginning of her sacrifice. Chapter 2. The Mother's Vigil. In the weeks following mating, the female octopus undergoes a transformation that would humble any human mother. Her body begins to swell with eggs, thousands upon thousands of them, each no larger than a grain of the rice, yet each containing the complete blueprint for one of nature's most sophisticated creatures. She seeks out the perfect nursery, a cave, a crevice, or the underside of a rocky overhang. Here, she will create what marine biologists call a brooding den, a fortress that will become both sanctuary and prison. The eggs emerge in translucent strings, like nature's own DNA helixes made visible. The female tends to each strand with the devotion of a master craftsman, using her 8 arms to arrange them in perfect cascades. She blows water over them, ensuring they receive the oxygen they need to develop. She tends them with a gentleness that seems almost impossible from a creature that can crack crab shells with ease. But here begins the most extraordinary sacrifice in the animal kingdom. From the moment she lays her eggs, the female octopus enters what scientists call reproductive senescence, a biological program that will ensure her dedication to her offspring at the cost of her own life. She stops eating entirely, not occasionally, not when food is scarce. She stops eating forever. Her body begins to consume itself. Muscle mass decreases. Her skin loses its vibrant colours. Her once powerful arms grow weak. Yet she never leaves her post. For 6 months, perhaps longer, she will guard those eggs with supernatural dedication. During this vigil, she faces constant threats. Hungry crabs scuttle past, drawn by the scent of developing life. Fish probe the entrance to her den, seeking an easy meal. But the mother octopus remains steadfast, using her weakening arms to brush away intruders to maintain the water flow that keeps her eggs healthy. It is a biological tragedy of Shakespearean proportions. The very act of reproduction triggers her death sentence, yet she embraces it with a devotion that speaks to something profound in the architecture of life itself. And then, after months of this selfless vigil, the miracle begins. Chapter 3. The Awakening. It starts with the faintest of movements, a barely perceptible trembling within the translucent eggs. After months of development, fueled by the nutrients their mother's body provided, the baby octopuses are ready to emerge. What hatches is not a miniature version of the adults we know, but something far more extraordinary. These creatures, called paralarvae, are no larger than a pinhead, yet they are already perfect predators. They emerge with functioning eyes, working chromatophores for colour change, and 8 tiny arms equipped with suckers ready to grasp the microscopic world around them. The mother, now at the very end of her strength, performs one final act of devotion. She blows water over the eggs, helping her offspring break free from their translucent prisons. As they emerge, thousands of them, like tiny jewels scattered in the current, she ensures they are swept away from the den and into the open ocean. It is her last maternal act. Within hours or days of this mass hatching, the mother octopus will die. Her body, consumed by months of starvation and the biological imperative to reproduce, finally surrenders to the sea. But her offspring face their own incredible journey. These paralarvae, each weighing less than a milligram, must now survive in the vast 3-dimensional wilderness of the open ocean. They join the plankton, that floating community of microscopic life that forms the foundation of all marine ecosystems. Here, in the plankton cloud, they are both predator and prey. Their tiny arms reach out to capture even tinier creatures, copepods, marine larvae, microscopic crustaceans. Their eyes, already sophisticated despite their size, track movement in the water column with precision that would impress any human engineer. But the ocean is vast, and these tiny octopuses are utterly alone. Unlike many marine animals whose parents guard them, teach them, or provide them with food, these paralarvae must learn everything from scratch. They must discover what is food and what is predator, what is shelter and what is trap. The mortality rate is staggering. Of the thousands that hatch, perhaps only 1 or 2 will survive to adulthood. They face an endless array of threats: jellyfish with trailing tentacles, fish with mouths that can engulf dozens of them at once, and countless other predators that see them as nothing more than floating protein. Yet those that survive begin to exhibit something remarkable, the first signs of the intelligence that will define their species. Chapter 4. The Education of a Genius. After weeks in the plankton, the surviving paralarvae undergo one of nature's most dramatic transformations. They settle to the ocean floor, their bodies changing from transparent drifters to the complex muscular forms we recognize as octopuses. But they are still tiny, no larger than a human fingernail, and now they face an entirely new set of challenges. The seafloor is a landscape of predators and competitors, where every rock, every crevice could hide either refuge or death. It is here that the octopus's legendary intelligence truly begins to manifest. Watch a juvenile octopus explore its environment, and you witness one of nature's most sophisticated learning processes. Unlike most invertebrates, which rely primarily on instinct, young octopuses exhibit what can only be called curiosity. They investigate objects, manipulate them, test their properties. They are, in essence, conducting experiments. Their skin becomes their first tool of survival. Those remarkable chromatophores, specialized cells containing pigments, allow them to change not just color, but texture as well. They can mimic the appearance of coral, algae, rocks, even other animals. A young octopus might cycle through dozens of different camouflage patterns in a single minute, each one a potential lifesaver. But perhaps most remarkably, they begin to use tools. In the waters off Indonesia, marine biologist Mark Norman made a discovery that revolutionized our understanding of invertebrate intelligence. He observed octopuses collecting coconut shells, cleaning them, and carrying them across the seafloor. When threatened, they would assemble these shells into protective shelters, essentially creating portable homes. This behavior requires not just intelligence, but planning. The octopus must envision future danger, recognize the protective value of the shells, and execute a complex sequence of behaviors to achieve its goal. It is a level of cognitive sophistication that we once believed was exclusive to vertebrates. As they grow, their learning accelerates. They develop individual personalities, some bold and exploratory, others cautious and methodical. They learn to recognize individual fish, remembering which species are dangerous and which are prey. They develop hunting strategies, often specific to their particular environment. A Mediterranean octopus might specialize in cracking open sea urchins, while a Pacific species perfects the art of mimicking flatfish. Each individual becomes a specialist, adapting its behavior to the unique challenges of its habitat. But perhaps most extraordinarily, they appear to learn from observation. Young octopuses have been observed watching other octopuses hunt, then incorporating those techniques into their own behavior. They are in essence teaching each other. Chapter 5. Masters of Deception. As the octopus matures, it develops into what can only be described as a living masterpiece of biological engineering. Its skin becomes a canvas capable of producing displays that would make any human artist weep with envy. The secret lies in those chromatophores, millions of them, each containing pigments that can be expanded or contracted in milliseconds. But that's only the beginning. Beneath the chromatophores lie iridophores, cells that reflect light and create metallic sheens. Deeper still are leucophores, which produce white coloration and can amplify the effects of the other cells. The result is a creature capable of what marine biologists call dynamic camouflage, the ability to change appearance faster than the human eye can follow. An octopus can shift from the mottled brown of a rocky reef to the pure white of sand, then to the rippling patterns of sunlight filtering through kelp, all in the space of a heartbeat. But this is not mere camouflage, it is transformation. The octopus doesn't just match its environment, it becomes it. Its skin can project three-dimensional textures, creating the illusion of coral branches, algae fronds, or rocky surfaces. It can even mimic the movement patterns of other creatures, undulating like a flatfish or flowing like a piece of kelp in the current. Perhaps most remarkably, octopuses have been observed using what researchers call progressive camouflage, moving across different environments, while continuously adjusting their appearance to match each new background. It's as if they possess an internal map of their territory, complete with a catalogue of appropriate disguises for each location. But the octopus's intelligence extends far beyond camouflage. They are problem solvers of extraordinary ability. In laboratory settings, octopuses have learned to navigate complex mazes, unscrew jars from the inside, and even escape from their tanks to explore their surroundings, sometimes returning to their enclosures before their absence is discovered. One famous octopus named Inky escaped from New Zealand's National Aquarium by squeezing through a gap in his tank, crawling across the floor and disappearing down a drain that led to the ocean. The entire escape was captured on security footage, revealing a level of spatial awareness and problem-solving that astonished researchers. In the wild, their intelligence manifests in countless ways. They use tools not just defensively, but as hunting aids. Some species have been observed using rocks as hammers to crack open shellfish, while others employ sticks to extract prey from crevices. They modify their environment, building dens and garden areas around their homes. Perhaps most intriguingly, they appear to plan for the future. Researchers have documented octopuses collecting materials and storing them near their dens, apparently anticipating future needs for shelter construction or tool use. Chapter 6. The Hunt. When an octopus hunts, it becomes a creature of liquid grace and calculated violence. Its 8 arms work in perfect coordination, each one capable of independent thought and action. Scientists have discovered that octopus arms contain their own neural networks, essentially mini-brains that can taste, touch, and react without input from the central brain. Imagine having 8 appendages, each with its own intelligence, working together toward a common goal. It is a form of distributed consciousness that we can barely comprehend. The hunt begins with reconnaissance. The octopus emerges from its den like a shadow-given form, its skin already adapting to the terrain. Its eyes, as sophisticated as any vertebrate's, scan the environment for the telltale signs of prey. Unlike human eyes, which move to track objects, octopus eyes remain fixed while the pupils, shaped like rectangles, adjust to maintain perfect focus. When prey is detected, the transformation is instantaneous. The octopus becomes a living weapon, its arms extending with hydraulic precision. It can attack from multiple angles simultaneously, with some arms grasping prey while others maintain camouflage or prepare escape routes. But perhaps most remarkable is its ability to predict prey behavior. Researchers have observed octopuses positioning themselves not where their prey currently is, but where it will be moments later. They are, in essence, thinking several moves ahead, a cognitive ability that rivals that of much more complex vertebrates. The kill itself is swift and efficient. The octopus's beak, a structure harder than steel, delivers a precise bite that injects both toxins and digestive enzymes. The prey is paralyzed and begins to dissolve from within, allowing the octopus to consume it without the need for chewing. 30. But the octopus faces its own predators, and here its intelligence truly shines. When threatened, it can employ a bewildering array of defensive strategies. The famous ink cloud is just one option, a smokescreen that not only obscures vision, but also contains compounds that interfere with predators' chemoreception abilities. Some octopuses have developed even more sophisticated defenses. The mimic octopus can impersonate other species entirely, taking on the appearance and behavior of flatfish, lionfish, or even sea snakes. It's as if they maintain a mental library of other creatures, selecting the most appropriate disguise for each situation. Perhaps most remarkably, octopuses have been observed using what can only be described as misdirection. They will create elaborate displays with some arms, while using others to prepare escape routes or defensive positions. They are quite literally master magicians of the marine world. Chapter 7. The Cruel Mathematics of Time. But here we encounter the cruel paradox at the heart of the octopus's existence. All of this intelligence, all of this sophisticated behavior, all of these remarkable adaptations, they are compressed into a lifespan that rarely exceeds 2 years. Consider the implications of this biological tragedy. While a human child is just learning to walk, an octopus has completed its entire life cycle. While we are still developing our cognitive abilities, the octopus has already mastered skills that would challenge adult humans, reproduced, and died. This brevity creates what scientists call evolutionary pressure for rapid learning. Unlike creatures that can rely on experience accumulated over decades, octopuses must become experts in survival within months of settling on the seafloor. They cannot afford the luxury of gradual learning. Every day is precious, every lesson potentially life-saving. 34. The result is a creature that seems to live in fast-forward, packing lifetimes of experience into months of existence. They mature rapidly, reaching sexual maturity within their first year. Their learning curve is unlike anything else in the animal kingdom, steep, intense, and absolutely essential for survival. This temporal compression may explain their remarkable intelligence. When you have only months to master the skills necessary for survival and reproduction, every cognitive advantage becomes crucial. The octopus's brain, with its 500 million neurons, represents evolution's solution to the problem of maximum intelligence in minimum time. Yet this same intelligence makes their brief lifespan all the more poignant. Here is a creature capable of complex problem-solving, individual personality, and sophisticated communication, yet it is granted less time than a human toddler to explore the world. Some researchers have suggested that octopuses represent a different evolutionary path to intelligence, one based on intensity rather than longevity. While mammals developed large brains to accumulate knowledge over long lifespans, octopuses evolved sophisticated neural networks to maximize learning within the constraints of brief existence. Chapter 8. The Final Season. As the octopus approaches its final season, its behavior begins to change. The urgent hunting, the careful den maintenance, the constant vigilance, all of these gradually give way to a different imperative. The drive to reproduce begins to dominate all other considerations. For the male, this means seeking out a mate, despite the certain knowledge that this encounter will be his last. The female, meanwhile, prepares for her own sacrifice, her body already beginning the biological changes that will ensure her devotion to her offspring. It is here that we see perhaps the most profound expression of the octopus's intelligence. not in problem-solving or tool use, but in the apparent acceptance of their fate. They seem to understand in some fundamental way that their time is limited, and they use every moment to ensure the survival of the next generation. The mating ritual, when it occurs, is both beautiful and tragic. The male approaches with displays of colour and pattern that represent the culmination of his brief existence. Every hue, every texture, every gesture is a desperate attempt to communicate his worth as a partner. The female, larger and more powerful, holds his life in her arms, literally and figuratively. After mating, the transformation is swift. The male's body begins to shut down almost immediately. His colours fade, his movements become erratic, and within days, he will join the countless generations of his species that have made this ultimate sacrifice. For the female, the process is more gradual but no less certain. As her eggs develop, her body enters that remarkable state of reproductive senescence. She will spend her final months in devoted guardianship, using her remaining strength to ensure the survival of thousands of potential offspring. It is a biological imperative so strong that it overrides even the most basic drive for self-preservation. She will literally starve herself to death to ensure the survival of her young, a sacrifice that humbles our human understanding of parental devotion. Chapter 9. The Eternal Cycle. And so, the cycle completes itself, as it has for millions of years. The mother's death coincides with the hatching of her offspring, ensuring that her final breath gives life to the next generation. Those tiny paralarvae, each carrying the genetic wisdom of their parents, begin their own perilous journey through the vast ocean. Most will not survive. The ocean is unforgiving, and the odds are stacked against them. But those few that do survive carry within them the accumulated intelligence of their species, the ability to learn, to adapt, to solve problems, and to transform themselves into masters of their environment. In the grand theatre of ocean life, the octopus represents something unique, a creature that achieves in months what other animals might take years to accomplish. They are living proof that evolution can create intelligence through intensity as well as longevity, that consciousness can burn bright and brief like a shooting star. Each generation of octopuses faces the same challenges their ancestors did: predators to avoid, prey to catch, mates to find, and young to protect. Yet each generation also brings new adaptations, new behaviours, new solutions to the eternal problems of survival. They are in many ways the ocean's greatest success story. Creatures that have mastered their environment not through size or strength, but through intelligence and adaptability. In their brief lives, they accomplish feats that would challenge creatures with much larger brains and much longer lifespans. The octopus reminds us that intelligence is not the exclusive domain of long-lived creatures. In the vast laboratories of the ocean, evolution has created a form of consciousness that burns bright and brief, like a candle in the darkness of the deep. Chapter 10. Reflections on the Alien Mind. In studying the octopus, we encounter something that challenges our most basic assumptions about intelligence and consciousness. Here is a creature whose last common ancestor with humans lived over 500 million years ago, yet it exhibits behaviours that seem startlingly familiar: curiosity, problem-solving, individual personality, and complex communication. This convergent evolution of intelligence suggests something profound about the nature of consciousness itself. Perhaps the ability to learn, to adapt, to solve problems represents a fundamental property of complex life, one that can emerge independently in vastly different lineages. The octopus's intelligence operates through neural networks that are radically different from our own. While our intelligence is centralized in a single brain, theirs is distributed throughout their body. Each arm contains its own neural networks, capable of learning and responding independently. It is a form of consciousness that we can barely imagine, embodied intelligence that experiences the world through 8 semi-independent appendages. Their perception of the world is equally alien to our experience. They see polarized light patterns invisible to us, taste through their skin, and communicate through colors and patterns that create a visual language of extraordinary complexity. In many ways, they inhabit a sensory universe that overlaps with ours, but extends into dimensions we cannot perceive. Yet in their brief lives, they achieve a level of environmental mastery that speaks to something universal about intelligence. They modify their surroundings, use tools, plan for the future, and adapt their behavior based on experience. They are, in essence, engaging with the world in ways that we recognize as fundamentally intelligent. The octopus forces us to expand our definition of what consciousness might look like. It suggests that intelligence can emerge from different evolutionary pressures, operate through different neural architectures, and manifest in ways that are both alien and familiar. Chapter 11. The Deep Mysteries Remain. Despite decades of research, the octopus continues to surprise us. New species are discovered regularly, each with its own unique adaptations and behaviors. The deep-sea octopuses, living in the eternal darkness of the ocean depths, have developed strategies for survival that we are only beginning to understand. Some species brood their eggs for years, not months, a remarkable exception to the rule of brief lifespans that defines most octopuses. Others have developed bioluminescence, creating their own light in the darkness of the deep. Still others have evolved to live in environments so extreme that they challenge our understanding of what life can tolerate. The giant Pacific octopus, largest of all octopus species, can live for up to 5 years and grow to span 30 feet from arm tip to arm tip. These ancient creatures, living in the cold waters of the North Pacific, represent the exception that proves the rule, showing us what octopus intelligence might achieve given more time to develop. But even our most sophisticated research methods can only scratch the surface of octopus consciousness. How do they experience the world through their distributed nervous system? What is it like to possess 8 semi-independent arms, each with its own capacity for learning? How do they integrate information from skin that can taste, eyes that can see polarized light, and arms that can think? These questions remain largely unanswered, reminders that the ocean still holds mysteries that may forever elude our understanding. The octopus represents not just a triumph of evolution, but a window into forms of consciousness that operate according to principles we can barely imagine. In their alien intelligence, we glimpse the vast possibilities of life itself, the countless ways that consciousness might emerge, develop, and express itself in the universe. They remind us that intelligence is not a ladder with humans at the top, but a vast landscape of possibilities, each shaped by the unique pressures and opportunities of different environments. Closing. The insane genius of the deep. And so we return to where we began, to the mystery of a creature that lives an existence so compressed, so intense, that it seems almost impossible. In the span of a single human year, an octopus is born, learns to hunt, masters the art of camouflage, develops its own personality, finds a mate, reproduces, and dies. It is a life that unfolds like a time-lapse photograph of intelligence itself, every moment precious, every experience essential, every decision potentially the difference between survival and extinction. The octopus's brief existence reminds us that consciousness is not measured in years, but in the intensity of experience. In their fleeting lives, they demonstrate capabilities that would challenge creatures with lifespans 10 times their own. They are problem solvers, communicators, artists of camouflage, and masters of adaptation, all compressed into a time frame that barely allows for a single human childhood. Perhaps this is what makes the octopus so extraordinary, not just their intelligence, but the impossible pace at which they must deploy it. They are evolution's answer to the question, how much consciousness can be packed into the briefest possible existence? The answer, as we have seen, is more than we might ever have imagined. In their alien intelligence, their impossible adaptations, and their tragic beauty, octopuses represent one of nature's most profound achievements, a form of consciousness that burns bright and brief in the vast darkness of the ocean. They live insane lives, insane in their intensity, their intelligence, their devotion to the next generation. They are creatures of genius and sacrifice, of intelligence and tragedy, of beauty and loss. And in the end, perhaps that is what makes them so remarkable. They remind us that consciousness itself is a kind of miracle, a brief flowering of awareness in the vast universe, precious precisely because it is so fleeting. In the depths of our oceans, where light has never ventured and pressure would crush human bones, the octopus continues its ancient dance of intelligence and sacrifice. New generations emerge, learn, adapt, and pass on their genetic wisdom to the next wave of these remarkable creatures. They are the ocean's philosophers, its problem solvers, its artists of transformation. In their brief, brilliant lives, they illuminate the endless creativity of evolution and the profound mysteries of consciousness itself. The insane life cycle of the octopus, genius compressed into tragedy, intelligence racing against time, love literally unto death, continues in the eternal darkness of the deep. And we, in our human understanding, can only marvel at the impossible beauty of it all. This has been Animal Uncovered. Until next time, may you carry with you the wonder of the octopus, a reminder that intelligence takes many forms, consciousness burns in many ways, and in the vast ocean of existence, every life, however brief, has the potential for genius.